inconvenience cost. Hope we are in this slide. So we have been discussing about adiabatic properties of the compounds and then top cut prediction of the compounds. These are the most crucial factors that need to be taken in account for predicting a drug properties, because when your drug is going to have a good pharmacokinetics and dynamic property, and definitely is going to have a less failures or can prevent the failures in the forthcoming stages of drug discovery and development. So I'll show you the demonstration. During that time, you all people can understand in a much detailed manner. And this is an example of a drug repurposing for an cardiotoxic. This has been drugs treated with it for a cardiotoxic and non-cardiotoxic drugs, and to visualize the gene expression data from cells. You can see here. And here they basically used in polypharmacological properties and drug repurposing using a transcriptomic data. Going back. Going forward, and polypharmacology, it's the most common and then I could say that booming pharmacological domain where the people try to handle a multiple drug targets. So if I take one disease and multiple drug targets, immediately it put me in a show of the cancer disease, because there only the network of pathways and metabolic inductions are happening inside the cells will try to make an rapid behavior and then growth of the cells. So in order to control that, or in order to see the how many compounds or efficiency in treating this disease, so definitely for in that case we need an database of compounds. From the database of compounds, we need to understand which compound is going to have a good efficacy. So we need to basically do investigations of databases using pharmacological agents. And moreover, one can also understand the drug interactions and associated mechanisms when we try to use a polypharmacological concepts. And this could lead to an alternative drugs for use of clinical trials without having a negative effects. So especially we have a ligand profiler tool and drug discovery stream where they try to utilize an multiple pharmacophores against multiple compounds, will screen and map and show you the efficacy of the compounds. That is actually the very easiest and the best way of screening big data as well as multiple targets. And as I stated earlier, you will know that I was telling about it. There are two approaches in machine learning. One is a DIY approach, and another one is an uh, pre-model approach or pre-built approaches. So similarly here, there are a statistical and predictive analysis in pipeline file that has been shown for you all. So here just you have to pick these components and then you have to execute the protocol. So more components you try to put together in a meaningful pipeline will help you to build one protocol, and that protocol can be executed for to screen your components. Let's briefly we see all these things. Don't worry. And for pipeline pilot learners, if you're a passionate R scripter, you have a domain over here also where you can pick your component and you can study in various kinds of machine learning algorithms and behaviors. And if you are native learners, you can pick those components also. But both are same, but they work in similar manner. But it depends upon the users which one they have to pick. That's why it's a versatile platform for any people who want to do the comprehensive research. And coming to the machine learning. So when I take a machine learning, we have basically supervised, unsupervised, and reinforcements. Under supervised, we have a regression classification. And when I say regression, it automatically falls into mind of a QSCR technique, where it basically uses a linear regression technique to form an ask for a value and to see for test inferior. Similarly, the applicable over here for supervised data also. And we also have classification data. When I say classification data, okay, there is something classification, carcinogen or non-carcinogen, mutagen or non-mutagen. So to differentiate the compounds in a binary manner, like good or bad, like that, we need a classification data. And unsupervised, it's basically includes a clustering, pattern search, and dimension reduction. Example, I could say that unsupervised learning. Most common example that we have been already introduced in a molecular dynamics simulation is a PCA. principal component analysis to reduce the dimension of your data and to understand the dominating conformations. And reinforcement, where we're using clustering and association. Let's see all the things in detail. And we have a lots of algorithm to address this. When you take a ML algorithms, it's basically statistical methods and more heuristic in nature. And one can use ML to accurately predict the outcomes of covariance that are provided. And supervised, as I stated, we have maybe Bayesian logistic regressions, and if we take classification, KSPMM, and neural networks include CNN, RNN, okay, and ensemble XBoost, and random forest, and unsupervised. We have K-means and pattern searches like FP growth and dimension reductions like a PCA. So all these are in a different kinds of ML algorithms will help you to address your drug properties and as well as the drug designing process. So first we see about supervised learning. Okay, this is a small example to represent in a very layman terms. I could say that you have to input your data, and then that's what we say: the train your model with a label given data set. Can be split into training and test. This is your training set, which you already trained, and this is your input data. And you apply your algorithm, choose any of these algorithm, linear regression or support vector machines, and random forest, any one of the method. And then process your data, and then when processing, it will try to predict your results and identify the accuracy of your model. So high accuracy of the model is the most important and appreciated and need to be done when you will be developing any models using supervised machine learning. So this is how the supervised machine learning will work out. Now unsupervised. This doesn't need your data to be labeled or classified. Just give raw input data and apply the algorithm, maybe k-means, principal component, or single variable decomposition algorithms. Apply your algorithm. The study will help you to understand and describe the hidden nature or structure of your unlabeled data. And once it processes and identify the patterns and gives you output data. So this is how this unsupervised machine learning will work out. The next is reinforcement, but it is automatically determine the behavior through its performance actually. So it will reward an environment and apply the algorithm and I'll get a better way. So this is the best way to perform given task is to learn from the experiences. And moving on, just to showcase you all the BioViat pipeline palette, this is in a window and you can see the various menu options and search options and help text and parameters, status bar, taskbar, and this is how this components, each component is being put together and they form like a protocol. And there are certain additional tools if you want to perform that also is there and favorites. So this is how this pipeline palette main window will be there. And the protocol always will be try to execute from the left to right and top to bottom. And how many protocols can one at one page you can have a many number of protocols also. And if you have more protocols, you can make a sub protocols also. It's up to the user perspective, you can make it out. And building a model. So this is an example of how I picked compounds, or I could say the drugs, and in a SD format, and I want to learn the genetic function approximations to use a parameter for discrete tasks. Okay, so I starting the training set by learn component to give a model type of GFE. First, I'm trying to learn this, and then I'm understanding about its nature, R square, and these are various statistical parameters I'm trying to analyze from that. And then I create this component created by a learning. So now it's learned, now it became a component. So now the model component created by learner will help you to make a predictions. So I'm giving a drugs, it will predict and say me the results. So whether what is a PVP, plasma protein binding of a genetic function approximation ensemble, it will try to predict. So what you learn from there, it will understand and it will help you to make a predictions. Okay. Similarly, the two ways of that, you can bring a component and you can edit the model of the component and you can execute the process. And also you can calculate various properties using by bringing in a customizing a script. The basic script that is involved over here is called pipeline palette script. It is not as tough like other programming. It is just very simple language that everyone can easily can grab and they can execute the process. So this is an example. So as I was stating about, I'd like to brief and detail about some of the algorithms, including Bayesian categorization and regressions, because how those two algorithms are playing a major role in predicting the drug properties. Let's take an example of maybe Bayesian classification. And the case study is I'm having a lots of drugs in my hand, and I don't know this is a good sample or a bad sample. How do I know that this is a good compound having a good maximum solubility and penetrating inside the blood-brain barrier and not binding to plasma protein? How I say that? I need certain features need to be described, right? The same thing I'm going to check it now by utilizing a Bayesian classification method. So let's consider my compound feature one. It's trying to put it in a various baskets or various bin. I could say that up to m bin it will try to sample. And if the feature is been mapping, say for an instance, good feature is going to map, then it will highlight and shows me the good features. And a bad feature is mapped, then it will be named as a bad. And finally, up to yum bin, it will identify and make me to make calculations, the features and the scores. And it will be calculated, and finally, I will get in the values. And from this, I can learn the good and bad fingerprints of present the sample that help me to distinguish malgrain versus tumors, spam mail versus non-spam, which is already been is a part of a Google, which is already using artificial intelligence. And moreover, when it comes to the compounds, it will help me to distinguish active and inactive compounds. And also it will help you to show about in what are the where is the imbalance training set should be used in a minority of classes, and good molecules will support a predefined of molecular structures. That's why each and every fingerprint is being taken in account when we try to implement the machine learning algorithms. And categories, you can learn the categories and then you can understand the multiple classification of your compounds. And this is how I executed this process. Say, for instance, I have taken a set of comp tracks and defined as an actives and inactives. On the other hand, I will trying to introduce another set of tracks, and then it is trying to it and get me the fingerprints and shows me the good fingerprints with the positive scores and bad fingerprints with the negative score. This is an example of ACE inhibitors and utilizes the fingerprints FCFP fingerprints of diameter 6. So understanding about the fingerprints will makes more interesting in study rather than studying the whole molecule. So if you see this fingerprint attached in certain position, that will definitely, I could say that for specific receptor, this is not considered as a good. So we need to remove this particular fingerprint and you have to replace with some other fingerprint to know whether it is still be considered as a good or not. So more the good fingerprints in the system, better efficacy of the molecules. Next. So top cat prediction or toxicity is the most important property that need to be done before going and to understand the drug properties. So it predicts the toxicity using classification or regression methods. So as I said, classification we already see maybe Bayesian. So similar technique we are going to apply. But here I explained about the fingerprints. Here also same process. But here we are going to predict the carcinogen, non-carcinogen, mutagen, non-mutagen based fingerprints actually. Okay. And then Topcat model, which will basically uses a training set data, and it is also known as a toxicity prediction computer assisted technology, and has been built using a Bayesian models and regression models using a PLS technique. And it is a classification model. It is a category of data endpoints, just whether your compound is carcinogen or non-carcinogen, and gender specific. It can able to distinguish and give results, and it uses a Bayesian analysis technique. And when I use regression models, it is a continuous dependent property, and it uses a partial least square method and helps me to further it helps me to understand about a therapeutic ratio of compounds and promising compounds for development investment. And also I can understand the intermediates, metabolites, pollutants, screen the compounds for a high throughput screening. This kinds of a method will bring more bolster to your pharmaceutical industries and agriculture industries to understand the product safeties. Moreover, you can also draw the conclusion, you'll get the information about the dosage range of animal assays. So let's we are going anyhow in a demonstration I will explain in detail about these methods. And Performing the process is also going to be very easy. You need to open Discovery Studio if you're already a user, but if you're not a user, we can see this picture where we're trying to utilize the protocols. In the protocol, Topcat prediction, just select the how many models which is being built using machine learning you want to utilize for your prediction of drug properties. Select the models and give a similarity search because in pipeline palette we already been integrated with the database of compounds, but you go and hit with the compounds and retrieve your results. And finally, you get a results like this in detailed report will help you to read more and give you more information about your compounds. So this is a compound where it go and hits with a database and sees for the similar databases. Like say for instance, you want to identify the gallic acid like compounds or apic acid like compounds. How it will do? It will go for either it will use a fingerprints or an numerical methods like LSDN or Manhattan. It will go on it. Similarly, here also it uses a Mann-Halon based distance method and identifies a structural similar compounds. When it is goes and hits with a non-mutagen and looks for the fingerprints and will be getting the results. And similarly, it goes and hits with an male in national toxicity program of a male or a female mouse and sees for the positive and negative contribution. In case certain fingerprints are going to make a negative contribution for this particular molecule, you can remove that fingerprint and then resketch it and then save it again and run once again. That will help you to understand more about how each and every fingerprints are being contributing for structural bioactivity. So you will draw the conclusion of SAR or even STR, structure toxic relationship also. In terms of an set dosage ranges, so you can also come to an rat predicted rat ATD50 value, oral LD50 value, inhalation value, and environmental models like a fat admino LC50 and Daphne AC50. So you can come up with a compound nature and the dosage ranges to before going to in vitro technology. And drug likeness, of course, are more important properties of a drugs, which you can calculate very easily by introducing Lipin's rule of 5, where you're predicting a log p value, molecular weight, number of acceptors, number of donors. Along with that, you'll be introducing Weber's rule of 5. So these are all the properties of the drugs. I could say that when your drug is going to obey these properties, then definitely it will have a good oral bioavailability. So all these things are need to be predicted and trained with your compounds before going for an in vitro study. In case if you have a lack of molecules and you want to screen and pick only the top 10 or top 20 molecules for in vitro study, we need a rational way of screening this technique. If you're going to use a machine learning based technique, then your outcome of results is going to be more efficient. That's what I can say that. And this is an example of how they identify the estrogen antagonist without doing a docking and just by using a machine learning algorithms. We try to introduce an LDA model using a basic R statistic technique. It's a linear distribution analysis to understand the estrogen antagonist based on the molecular descriptors. So we'll be training your antagonist molecule descriptors and trying to see whether this particular fingerprint is going to match with your some of the compounds to behave like a estrogen antagonist or not. So I'm just giving a training set and baseline molecules and marking as estrogen antagonist like a in a command window, and then I'm learning this component. After learning this component, I'll be understanding that ROC curve. If my ROC curve is going to be very good, that shows the efficiency of a model. If it is less than, see, it is in 0.95 is very really good. If it is above zero point 0.8, that itself is good. If it is less than zero point 0.5 or zero point 0.4, then again I have to consider my training set. Then again I have to restart this work and learn my component very well. Once I learn, I execute the component for the further studies. Now, after doing that, since my ROC, recursive operating characteristic seems to be good, now I'm utilizing that and I'm taking that one and I'm going for a further analysis. And it will help me to distinguish between false negatives and false positives. And automatically it will fix the coordinates and finally I get the results. So results looks like this, false negatives and false positives, which help me to distinguish the compounds and then I will get in the scores. So this is a very, very easiest way, even if you have millions of compounds also, instead of doing a docking and then analyzing and taking up of other results, this technique will help you in and help you to screen very efficiently in a very shorter span of time. And this is again another model. This is using a same process, but I implemented the different algorithms. I could say that different. This is used as a neural network model, deep neural network model, rather than the R neural network. Okay. So DNN components are more advanced for building much faster than the neural components. And usually it goes in a hidden network and then simply form the layer and identifies that. So here also same, I'm taking a component and learning with the neural network. Once I learn and I found ROC is perfect, then I'll be executing and understanding the false positives and false negatives. So by doing your process within different methods will help you to even understand about how much samples is trying to pick in the false positives and false negatives also. We can come make a comparison data like that. And the application of this one will of the machine learning is not limited. Will help you to understand the disease and diagnosis, personalized treatment, behavior modification, drug discovery, manufacturing, radiology and radiotherapy, smart electronic networks, smart electronic health records, epidemic outbreak predictions, and clinical trials. So it is not limited. It is a very having huge applications. I could say that. And moreover it also helps to identify and diagnose diseases, especially in terms of diseases like a cancer, precision medicine and multiple therapeutic things. And then also to treat say for instance by predicting your facial expressions you can able to treat the patients whether they are on depression or how much modulation they have depressed. We can able to treat them with the drugs. And today, what we are doing is in a cancer patients, example in colon cancer, we are giving a one drug for treating all the people. Some are being efficient, some is no efficient, some are having adverse effects. But in tomorrow, as I said, we are going to have a bean in your hand. We are going to extract these samples, and with the DNA, we are going to identify the biomarkers. With the expressions of the biomarkers, we are going to treat them with the different kinds of drugs. So the efficacy is going to increase. So drug discovery manufacturing, it also is not limited. It is having a huge success rate in, I could say that huge success rate in the next generation sequencing also. And also you can identify the disease mechanism and alternative pathway seems to be a front of in the space. And these are our customers partial list and our customers in life sciences across the world and academic government and the academic partners. And let's see the demonstration. I will show you a demonstration. I'll open Discovery Studio and I open the pipeline palette also and show you the same. So let me pick it's already running. That's fine. I can run the multiple jobs. There is no limitations in running a jobs in Discovery Studio. Okay. So for predicting ADMK properties, totally have 200 and 2915 molecules. So in that I'm trying to give alls and predicting the results. So it will run in a very fast pace. So it's predicted within a 5 seconds. When I double click and open, view results, I can understand the properties of my drugs. So anything it's out of the optimal prediction space or ellipse will not obey the drug likeness properties or drug properties. So show the legend. So I'm going to sort it based on the levels. These are predefined levels in Discovery Studio. So filtering of having good solubility will be greater than uh, 3 and blood-brain barrier level I could say that greater than or less than because 0 and 1 less than or equal to 1 and prediction of CPU if it's inhibitor or non-inhibitor which equals to false and hepatotoxic it should be non-hepatotoxic that means should not be cause any toxic so equals to false hepatotoxicity predictions actually. equals, one sec, prediction equals false. So next I have absorption. I'm not going to touch absorption because when I try to optimize one level, automatically other level will try to. And plasma, it should not bind to plasma protein binding equals to false. Name, apply, okay. So when I have a 2915 compounds, only 7 compounds are obeying the drug properties. That shows, see how fast the tool is working and how efficiently it's predicting the drug properties and how well the machine learning algorithms are paying a way to identify those results. And similarly, it applicable for a top cat prediction. Let me open and show you all compounds. I'll take only the visible. Okay. Let me take only the visible. The compounds one. Okay, visible. Let me take only 2 compounds and show you the results. Let me predict the Ames intensity. And even if you want, okay, I forgot to include, okay, I can see the rat healthy 50 LC50 value also. Click on. So multiple protocols you can run at a time and, different protocols also you can run at a time. I think it's finished. I can close this. It's preparing a report. Fine, it is completed. So detailed report, when I click the detailed report, so it will show me the properties and then a positive contribution of the compound, negative contribution of the compounds. Okay, and you can see the view results. So along with this, you can add one more parameter of the rats. So like this, you can do the n number of properties of predictions using biometric discoveries to do. Now let me show you the a pipeline pilot, how it is working on and how it is executing the process. Pipeline pilot 2021 version. So I want to do the estrogen antagonist. So already I built that protocol. So I'm just trying to call in a estrogen. So where is it? So to find that, first let me choose an LDA model. Let me learn the model first. So I have taken my input is my compounds and the drugs. Let's run this. So we get the ROC curve and stating that supports importance. And we got the results and showing ROC curve efficiency and then whether it's active or inactive. After learning this, I'm going to use an LDA model. It will predict and show me false positive, false negatives. See here I'm getting a false negatives. Decision exactly in here it says is active, but according to the prediction showing inactive. So like this, I can able to predict the compounds. Once I train the compounds, I can train with the number of molecules to understand this activity. Same process you can do with the neural networks also based on fingerprint 4. All you need is in the compounds and then the drug likeness compounds. The parameters you can see your compounds, precision antagonists in the SD format. And similarly, you get the ROC curve predictions, and if it gets satisfied, then use this more to understand the false positive and false negative compounds. So this is how one can screen a millions of compounds in a short space of time and to increase uh, space and time and accelerate your research process in drug discovery and development. And also you can understand the drug properties. And thank you all. That's all for today's sessions. And if you have any queries, feel free to post us. And we are very happy to share, look for your queries. And if you have any queries, feel free to comment in inquire at Altum or follow us in Altum Technologies YouTube channel and LinkedIn and Facebook. We are very happy to engage with you all for any queries at any time and to understand and help you all to resolve lots of problems in drug discovery and development. Thank you so much, all. Catch you all soon. If you have queries, feel free to ask us. We can have a discussion. Okay. Or you catch up me with an inquiry at altum.com. It will be directly directed to me for inquiries, and I'll catch you all personally. Thank you all. See you sometime. Bye bye. Take care. Have a nice evening.